Here we're looking at something that has the word inscribed. What does that mean? Well, we're gonna find out right now. You can Google it. You do a quick Google search on this, and you'll find out what it means, or you can just listen. Inscribed means that something is inside something else, and it just barely fits. So if I have, what does it say? What is the area of a circle that is inscribed in a square? So the circle is inside the square. So I'm going to draw a square first. So I have my square and my circle inscribed in it just means it just barely fits. Close enough. So pretend with your brain that's touching, that's touching, that's touching, and that's just barely touching. So what is the area of a circle that is inscribed in a square of area 7? So if I have a square like this, these are equal in length. So this, I'm going to say, let's call it x, and that means this is also x. So x squared has to equal 7, which means x is going to be the square root of 7. That's great. That's really nice. But here's the thing about inscribed shapes. They share lengths. Because I know that the diameter of the circle is the same as x. Because look at that. So the radius is half of x. And if x is the square root of 7, then that means this radius is from there to there. That is the square root of 7 divided by 2. So that's pretty good. And then I'm trying to find the area of the circle. Okay, and I just used my area formula for a circle. Area equals pi r squared. So then I got, you just have the area equals pi times the radius squared. So that's the square root of 7 over 2, and I'm squaring that. And when I square a fraction, I just square the top. That's going to be regular 7. Square the bottom. That's going to be 4. You get on my face. 7 over 4. And then times pi. That's what I have there. Easy, very easy. Units squared, because we're talking about area. Let's move on. Alright, let's see if this works. I made up this example. I don't know if it's going to work. We'll see. In the figure below, and it's not drawn to scale, AC, which is air conditioning, but in this case, it's probably a geometry problem. AC is tangent, so AC is tangent to circle E at point B. Great. If CE, there's this length, if that's 30 and BC is 12, what is CD? So I'm trying to find this length. Whoop. Now, really, I can just find the radius. Because I have this whole thing is 30. If I just find the radius, then I can do 30 minus the radius, and I get this. So that would be really easy. But here's the thing. There's a theorem in geometry, and hopefully this will make sense, that says if you have a line or a segment that's tangent to a circle, then you can draw another line, actually draw a radius of the circle from the point of tangency, and you're going to get a right angle right there. So look at this. I get a triangle, a right triangle, and I have one leg. Here's another leg, and I have the hypotenuse, and the hypotenuse is 30. So I can use Pythagorean theorem to find this length right there, to find the radius. And the radius is the same as DE. So this and that are the same. Of course it's the same. It's the radius of a circle. So what I'm going to do is I'm going to have 12 squared. Maybe I'll call this R plus R squared. And that is going to have to equal 30 squared, because that's the length of the hypotenuse. And then after I find the radius, I'm going to do like I said I was going to do. I'm going to take 30 and I'm going to minus the radius, and then I get CD. Okay, pretty easy. So what do I do here? I got 144 plus R squared equals 900. I'm going to subtract 144, and I get R squared is 756, and I square root both sides. That means R is the square root of 756. And I can reduce that. I'm just going to reduce that real quick right now. 756, I can divide that by 4. So that'd be 4. That's a perfect square. What is that? Divide by 4 equals 189. Divide that by 9. So I get 2 perfect squares. Great. And that's 21. 21 is 7 and 3. 7 and 3. 7 times 3 is 21. Okay, so this part, I know this comes out as a 2, because I got a pair, and that comes out as a 3. So I got 6. So this is just, hopefully you understand how to do this by now. 6 times the square root of 21. So that's what r equals, except for I'm not trying to find r, I'm trying to find CD. So I have to take 30, which is CE. So my answer is going to be 30 minus 6 times the square root of 21. And I'm just going to leave it like that. I'll get an approximation, but I'm going to leave my answer like that. And that's approximately 2.5-ish. 2.50. That's a pretty easy one. So the idea here is that when you have a tangent line to a circle, or a tangent, some segment that's tangent to a circle, it makes a right angle with the radius of that circle. If you draw the radius from the center to the point of tangency. Well, that's pretty nifty. That's pretty neat, okay? And I'm gonna be done. Goodbye.